This episode of Fluid Power Forum is sponsored by IFP Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFP spans the 13 central states from Minnesota to Texas. For more information, visit ifpusa.com.
The act of having a functionally safe machine is actually more like declaring to the public, we thought a lot about the detail of the safety functions of our vehicle and its response to failures, and we also have the documentation to prove it.
Welcome to the Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your guest host, Ben Brown. Here at the NFPA, we like to make sure that everybody on the forum has an equal platform. So we will be taking this holiday window to re-release episode 136, Demystifying Functional Safety in Mobile Hydraulics. Featuring Marcus Herrera, take the time this holiday season to remember the importance of functional safety in our work. Make sure you tune in for our exciting episodes coming up as well. We'll be kicking the new year off with a Year in Review podcast featuring leading journalists in our industry to discuss the biggest news, innovations, and trends from 2025. After that, we'll be highlighting some of our members who will be exhibiting at ConExpo ConAg this March. If you'd like to be part of our show, please follow us on LinkedIn at the National Fluid Power Association. If you see an interesting application of fluid power and want to learn more about it, share it on social media with our hashtag #OnlyFluidPowerCan, and you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to the show. You can find us on Apple Podcasts, Spotify, or any of the other podcasting services, and give us a quick rating so more of our friends in the industry can join these important conversations. Finally, we wish you all a wonderful holiday season, one of peace and joy with family and friends. We are grateful for your continued support and are excited to continue promoting our industry and the work that all of us do. Now, let's get into the episode.
So, Marcus, welcome back to Fluid Power Forum.
Hey, Eric, thanks for inviting me back to the show. I literally can't believe it's been 4 years since my first appearance. Where's the time gone?
Yeah, that's as soon as we want people back on the show. So you'll have to wait yet another 4 years to come back again.
That sounds great.
If that's what happens. No, we're happy to have you back on the call. Yes, we were reminiscing before we turned on the recording here about your last appearance on the show, but we're glad to have you back. Tell our listeners a little bit more about you in case they didn't hear that episode from 4 years ago. What is your background and how did you find yourself working at HYDAC?
Yeah, thanks. I appreciate that. Well, I'm a Texas kid originally, born and raised, and went up to school at Iowa State University. And then I graduated with my mechanical engineering degree. Didn't quite know what I wanted to do, but I loved Ames. And by the way, if you guys are Iowa State fans, we just beat the Hawkeyes this weekend. So
oh my gosh.
Go State.
The date of this recording is September 10th. So I don't know if people will realize exactly what game you're referring to, but
well, yeah, December 10th, 2024. Don't you forget it.
Right.
We got another one in the books. So at the time, I didn't really know what fluid power was, but a big company in Ames, Iowa is Danfoss Power Solutions.
I've heard of them.
And
I heard of them.
I was kind of spinning around trying to figure out what I wanted to do with my life. And my senior year of college, I did an internship there, fell in love with the company, had a great boss, and stuck around full time after that for about 4.5 years. Later on, I found an opportunity for a career move, and I took on HYDAC. And so it's now already been 5.5 years at HYDAC, and I just feel like time is just continuing to keep getting faster.
That's great. So you really kind of grew up in the industry then. When you were at Iowa State, were you mechanical engineering, did you say?
I was mechanical, yeah.
Did you must have had fluid power. You must have had fluid power exposure at that great school back then when you were a student, right?
I did. I think my junior year, there was a couple clubs that I was thinking about getting into, and one of them specifically was a fluid power club. I didn't actually do it though, so don't tell anyone. But I also did have an engineering class where we learned about hydraulics. I remember the lab in black engineering where we did it, but I don't remember what the class title was. So
okay.
Maybe some students someday can comment on this and let everyone know what class that was.
Well, they have multiple classes, as I'm aware of, at Iowa State that have hydraulics in them. So who knows? But anyway, you're at HYDAC now. So tell us more about HYDAC as a company. What does it do?
Yeah. So HYDAC is a family-owned company, and it's privately owned and operated, which manufactures essentially every product that you need for hydraulics, electronics, fluid conditioning, and also thermal management. I think the key here is, and HYDAC's core strength is its talented team who are trained and encouraged to really seek out ways to collaborate with its customers. HYDAC believes that true innovations occur when there's a partnership and there's a co-development between HYDAC and the customer. HYDAC is an expert in system design and development, and the customer is an expert in their machine and their industry. So when we come together in a partnership, we really feel like both parties can do their best work.
And as we've joked about earlier, you were on the show some years ago. I know we've had other HYDAC folks on the show as well over the years. You guys seem to be doing more and more things, if I remember correctly. You're moving into more product areas than ever before, and really becoming a full service hydraulic supplier, right?
I would say so, yeah.
Yeah, great. Well, we brought you on the call today, on the podcast today, to talk about functional safety, and that is the theme of a presentation, as we said, that you gave at the recent IVT Expo trade show. And from my point of view, you appropriately called it demystifying functional safety, because I think it's one of those things that maybe there's some people out there who don't even know what we're talking about when it comes to functional safety. What is it? So maybe we should start there. Can you explain what functional safety means and why it's important in the context of hydraulic systems?
I appreciate that you said that. I feel like it's going to be very difficult to do this with only words, but I'm going to do my absolute best.
There's no whiteboard, exactly, right?
There's no whiteboard. There's no presentation behind me. So I think the best way to start is to start with a formal definition from Wikipedia, which I know is a totally trusted source.
Great.
Functional safety is a part of the overall safety of a system or piece of equipment that depends on the automatic protection operating correctly in response to its inputs or failure in a predictable manner. The automatic protection system should be designed to properly handle systematic errors, hardware failures, and operational and environmental stress. So I guess really the real question is, what the heck does that mean? What did I just say?
Yeah.
I think an important thing is to focus on the automatic protection part of that definition. So if something were to fail or something were out of ordinary were to happen, that system should be built in a way to handle this failure in a hopefully safe, repeatable, depictable way. Mm-hmm. An example of something failing safe that we commonly see today in industry is the response of a fan in a cooling circuit. So let's say there's a failure in that system. Most of the time, that fan is designed to fail high or to default in a failed state at full displacement. In reality, that failure mode reaction alone doesn't necessarily make it functionally safe. But the idea that I'm trying to portray here is that something can fail and default to a state which is safer for the machine, the operator, or the environment. And that really is the core thought process behind the purpose behind functional safety. Mm-hmm. There are also a few terms that we like to use a lot when we talk about functional safety. So I did think it could be good to talk about those now. And in the definition we read, that functional safety is part of the overall safety of a system. So this term system here is referring to a group of interacting components. And like in a very overly simplistic view, a machine system is a simple input, logic, output. So for the sake of an example, let's pretend that you're up in an aerial work platform 45 feet in the air, mm-hmm. Eric.
Yep.
The input is the joystick in that bucket for you, which when you move, uses a controller with logic to send flow into cylinders. And then that output is you moving around in the bucket, right?
Right.
So within functional safety terminology, there are additional functions that support that system and contribute to the overall safety of the machine. So a couple of these could be limiting the speed of the ground drive if the bucket's in the air, maybe monitoring the stabilizers to make sure they're fully out and making good contact with the ground, or maybe limiting the amount you can extend past center to prevent tipping over. Mm-hmm. So when we think about functional safety being considered on the machine, it's important to know that not every system function is considered to be a safety function. And I'm going to be using those terms quite a lot. So I think that's a good thing to keep in mind. The functional safety documentation will state which functions on the machine need to be considered safe, and will also assign a required safety rating in order for you to achieve those.
Right. Well, that example that you just offered there with the aerial lift platform, that's there's still a human trying to control that, the movement of the machine, if you will. But one of the issues that we're facing increasingly is automated functionality of these systems, and that must raise the functional safety concerns to an even higher level, I'm assuming.
We are going to talk about that later today, I think.
We'll get into that. Right. Well, maybe I know during your presentation you talked a little bit about some common misconceptions or other challenges that people have when they try to wrap their head around what functional safety is. Do you want to comment on what some of those misconceptions might be?
Yeah, sure. I'd say in general, functional safety is unfortunately a topic that just has a lot of intricate details and moving parts. And each of these moving parts has a piece in the total calculation. And because of that, it's pretty confusing. For me personally, when I first started learning and hearing about functional safety, I thought functional safety was similar to like an EC certificate, which is to say that it's a certification that you achieve after passing a set of standard tests. But functional safety actually is probably more along the lines of a thought process. It starts in the earliest stages of development for your machine. It's the design and documentation of how a machine or a safety function on that machine handles failures and errors. And some of these errors could be, the cause of a premature failure of a product, foreseeable misuse of the machine, systematic errors, environmental influence. I think the act of having a functionally safe machine is actually more like declaring to the public, we thought a lot about the detail of the safety functions of our vehicle and its response to failures, and we also have the documentation to prove it.
Yeah. We'll continue with the show in just a moment, but first let me share some exciting news about our Fluid Power Forum podcast. We're launching Fluid Power Forum Plus, a premium listener membership offering exclusive content and special event opportunities for our most dedicated listeners. When you sign up for free on the NFPA website, you'll be able to unlock exclusive episodes, live recordings, transcripts, and invitations to private networking events, each offering even greater insights into interesting and innovative applications of fluid power technology. The first of our special events is now being planned for the NFPA Technology Conference being held at the ConExpo ConAg Trade Show in March of 2026. Fluid Power Forum Plus members will receive discounted registration for the conference, plus an exclusive invitation to attend our live taping of the podcast there, and a members-only networking reception following that taping. This will be a huge opportunity to gain insights into the innovations happening in fluid power technology and to meet up with fellow listeners and build your network. And that's just the start. More exclusive benefits will be announced soon. To register, head over to nfpa.com/plus. That's nfpa.com/plus. When you say documentation, I think you're referencing there are standards that exist that help guide engineers through these functional safety concerns and processes. And so I know, I'm going to let you describe what those standards are. But I know there are two main ones. So maybe tell us about those and give us a high-level overview of what they are. Correct?
Exactly. Yep. Yeah. So I think most people have heard of IEC 61508 and ISO 13849. And in the presentation that I gave at IVT, I mainly talked about the differences between these standards. But for the sake of this podcast, I actually want to start with the similarities first.
Right. Okay.
So I think it's important to note that both of these standards, so 61508, 13849, they're both a measure of a system's PFH value, or probability of failure per hour. Now, 61508 defines this as SIL, safety integrity level, whereas 13849 defines this as PL, or performance level. So again, just a reminder, both safety integrity level and performance level are both measuring the same thing. They're both measuring probability of failure per hour. And this PFH is expressed with 3 key requirements for the safety function in a system. So the first requirement is the degree of redundancy, or in other words, the structure of the safety function. The second is the degree of fault detection. And the third is the degree of reliability, or the confidence level that there are no design flaws in that system. So of those 3 key components or requirements, 61508 refer to those as systematic capability, and that's seen as the qualifiable measurement within that standard. ISO 13849 refers to those 3 keys, it comments on those 3 keys with a thing called MTTFD, or mean time to failure dangerous, and they use that as the form of a quantifiable measurement. So I just spoke a lot to you, and I know it was a lot of words.
Yeah.
But I had kind of like an aha moment when I was wrapping my head around functional safety, and I want to share that with you, Eric.
Oh, please. Yeah.
So imagine with me your favorite sports car. So what is your favorite sports car?
Gee whiz, boy, that's a tough question. Let's go with a Porsche 911.
Okay. Interesting choice.
Yeah.
And for me personally, it's a 1968 Ford Mustang Eleanor Edition Fastback.
We could go with that if that's more conducive to your example.
No. Let's just imagine your 911.
Okay.
Right? When you think about SIL is essentially asking the question, does my sports car have brakes, and are my brakes big enough to stop my car? And performance level is asking the question, how long do my brakes last, and is it satisfactory for the speeds I want to travel? So they're both asking a similar question, but they're posed in a slightly different way, and and the fact that SIL is just saying, do they exist, whereas PL is saying, do they last for a satisfactory amount of time?
Yeah. So just react. There's a deep process, a thought process that has to go through. Someone has to go through to apply these concepts to their specific application. You're not measuring the same thing in each application per se. You're trying to assess, as you're describing, the risk level for failure might be one way to say it, if I'm hearing you right. And that's a different calculation depending on what the different pieces of the machine are, right?
Yeah, like I said, there's multiple moving pieces, and really, when we're talking about SIL and PL, we're really only talking about one part of the pie. And there's really like 5 different equations that all feed into what we globally call functional safety. We'll talk just a little bit more about those later, but what I mentioned earlier, I mentioned the degree of redundancy, the degree of fault detection, and the degree of reliability. I would say those 3 keys are a really good synopsis of what functional safety is, and referring to a safety function on a machine. Okay. And now here's your first big test, Eric. When I say safety function, what do I mean by that?
A safety function is a process to limit the risk of injury? I'm guessing. You tell me.
So it's actually just referring to the fact that a machine can have multiple functions, but not every function requires safety.
Okay.
So when we talk about functional safety, we're actually only referring to the functions on a machine that your specific type code has declared as needing safety requirements.
And the type code is something that you determine by applying one of the standards that you've talked about.
Yeah, I think maybe this is a good segue into the next question here.
Sure.
So we're talking about what's this methodology and how does it apply?
Right.
Why is it significant?
Exactly.
So in general with functional safety, there are 3 types. There's type A, type B, type C. Think of it like type A is the parent, B is the child, and C is the grandchild. So on top, type A, it's considered the basic safety standard, which all the other functional safety documents pull content from. Type B standards, or that middle column, they call them group safety standards. And for all intents and purposes, the group safety standards divide the standards into respective industries. So think off-highway and on-highway. Lastly, you get the type C standards, and those are usually referring to specific machine genres. So we can think of agriculture equipment, forestry machines, or earth-moving vehicles.
Mm-hmm.
So we talked about 13849. Now 13849 is a B type standard, so it's a group type standard. So it goes through the lens of an off-highway industry. And it also, we learned earlier, defined performance level. So because of that, it's the main standard which most of the C-type standards in the off-highway market refer to and pull their main level requirements and verbiage from. So let's, for example, let's pretend that there's a segment on functional safety at the next NFPA annual conference on February 25th and 27th in Tucson, Arizona.
Fantastic. Thank you. Thank you for the plug.
Eric.
Yeah.
That's right.
I'll have to put you in touch with our
though,
conference scheduler to see if we can get something on the agenda for you. But please go ahead.
You picked it up.
Yeah.
Yeah. Okay. So let's pretend on that functional safety presentation that I'm giving, you find yourself sitting at a table with a yellow manufacturer for construction, a red manufacturer for agriculture, and maybe a green manufacturer for forest.
Right.
So each of these people are going to have their own industry-based C-type standard. But each of those C-type standards are all pulling how-to and best practices and verbiage from 13849. So again, in summary here, the purpose of the C-type standard is to define the safety functions and the required PL level required for those safety functions, but using very specific language and focus for that industry.
Right.
Because the requirements aren't always the same between different industries and machines.
So the B level standard, which it sounds like is at the ISO level, are the C level standards also ISO standards, or are they more specific than that?
There are IEC, EN, ISO. All of them have C-type standards.
It depends on what industry we're talking about, probably.
That's correct.
Or what machine grouping we're talking about. So okay, but they all refer back to ISO. I'm already lost the number here. 13849 as kind of their main outline for how they what they direct the engineer to do to assess and then correct whatever the safety issues are on the machine.
Yep, that's exactly it. You're getting it, Eric.
Okay, slowly but surely, I'm coming along. So great. So are there other things maybe we can talk about this at the machine level, the machine builder level, and what they're doing with this information, and then we can talk about it at the hydraulic architecture level. The hydraulic supplier must be doing different things as a result of this for functional safety reasons. Is that a good way into our next segment here on describing how this works?
Yeah, I think so.
Okay.
How about we start with the builder, and let's talk about component selection.
Okay.
So when you're calculating the total performance level of a given safety function, let's say you're doing this performance or functional safety process, the other parts that are required for that individual calculation are the individual components MTTFD value, and then the category and diagnostic coverage of that safety function architecture, which again, I'm going to remind you, those two things are very similar to the degree of redundancy and the degree of detection. So if you're interested in releasing that machine into the market, there's documentation that your supplier should be able to give you with all the data needed for those calculations, as well as giving you some hints towards how to use that component in your system.
Mm-hmm.
So, for example, HYDAC or other functionally safe ready suppliers will give its customers MTTFD values when applicable, and also help teach you how you can use that component within different circuits or system designs to achieve a certain level of category if needed. And when you combine both of those two pieces together, really the last step you need to do is plug a couple of variables and values into a formula to calculate your diagnostic coverage. And you now have enough information to justify and calculate performance level of your safety function. I want to remind you, though, that this process right now is sounding kind of like a certification, but functional safety really shouldn't be thought of in the lens of a certification. It's more like a guideline that engineers follow that says with the proper documentation and due diligence, this engineer and this company can stand up and confidently say that when my machine is used within proper boundaries of operation, it should be safe for its operator and environment.
Right. Well, and that's really that's the key piece to all of this, right? So we're talking about, especially when we talk about hydraulics, we're talking about tremendous forces that could potentially injure somebody if they're used improperly. So it's important to make sure that you're dealing with these functional safety concerns in a rigorous and methodical way, and that's what the standards help lay out, if I'm hearing it right.
You're absolutely hearing it right.
Yeah.
And I think it's also important to note, too, that the difference in industry changes the way that you approach this problem. So, for example, I want to we just talked about components.
Yeah.
Software is also a really big piece of this. So let's talk about software for a little bit.
Okay.
Now let's compare the difference in software between a large row crop type tractor and a small construction machine you might find in like a rental yard or a gardening side business. So I want you to think, Eric, about the difference in the environments between these two vehicles. Right. So the large agriculture machine is going to spend almost all of its life harvesting a field of crop, and maybe the most dangerous object nearby it could be like a lake or a tree.
Yeah.
That small construction machine is going to be in and around homes, roadways, sidewalks. There's going to be an unknown amount of inexperienced operators using it. And usually when you find those little machines, there's other workers right next to it that are needed to help while it's working.
Right.
So the risk of potentially dangerous situations and maybe the frequency at which they happen is significantly different between the two of them. And you might say when you're looking at that large tractor thinking like, wow, this machine looks like it could drive through a building if it wasn't safe.
Yeah.
But it's also important to remember the frequency and the potential risk of where these environments are. So because of that, the way that these machines react are also different. So if you're thinking about that small excavator again, let's say it's digging along the side of a road and the controller sees an error, it's very, very likely that it can send a stop command and the machine can just kaput right there. And that's the safest mode for it to be in.
Right.
But if you're driving down the field with a bin full of grain and your controller senses an error and wants to stop, if you slammed on the brakes, I'm pretty sure your face might hit the windscreen, right? So there needs to be some sort of like a ramp in the deceleration. And so I guess the point is even though both of these machines are reacting to an error and stopping, even that stop needs to be considered of how are we stopping? What is the safest way to stop?
Right.
And is this going to be safe for everyone around the machine?
And software is a big piece of doing that, I guess, right? That's what you're describing. It's like the control system is increasingly controlled by software.
Yeah, I mean, so both of those scenarios, the error led to the response to the error, whatever that error was you need to stop your machine. But the way that the software stopped the machine looked completely different. That big machine has some ramp down. Maybe it's even estimating the load, or it knows the load because these machines are getting so smart nowadays, Eric. It probably knows how much weight's in the grain bin already.
Yeah.
And you can modulate how quickly it stops you based on either whether you have a grain bin and connected on the back, or based on how much weight it has. I mean, really the software controls is getting pretty significant nowadays.
Yeah, I struggle with that word "know" when we're talking about sensors and computers and things like that. But it certainly senses all kinds of factors on the machine very quickly and can react much more quickly than people can in those spaces, right?
Absolutely.
Yeah.
Yep.
All right. So we've talked about a lot. It's been fascinating for me to learn more about this topic and how engineers approach it. What advice would you give to an engineer or a manufacturer who is just starting to incorporate functional safety concerns into their machines, especially those with hydraulics on them? How would somebody start this journey?
Yeah, I want to draw a parallel to functional safety and to electrification. I would say both engineers and manufacturers who are getting into these key things early, before they're widely mandated or required, definitely could have an advantage on the amount of experience they gain internally. But of course, there's going to be a cost benefit to being an early adopter, just like anything. Not every supplier will be ready to support your integration. Just like not every machine user or end buyer is going to see the need or benefit to pay for a potential increase in cost.
Right.
So that's definitely one thing to consider is what's the market availability rate and take rate before you start. But just like you mentioned earlier, Eric, as the U.S. mobile hydraulic industry continues to see advancements in technology and in general just has more requests for features like automated functions or autonomous operations, the expectation is that that machine has the ability to move and make decisions with minimal user input. And I would argue if this is a goal for your machine or your market, functional safety definitely should be a more important topic to discuss and wrap your heads around sooner than later.
Yeah. Well, it's interesting to me that, one of the through lines that I've heard on so many episodes of Fluid Power Forum is the need for the OEM and their fluid power supplier to work together on these complex issues. And this sounds like another one of those, right? That the answer is collaboration across the supply chain rather than trying to do these things independently. It sounds like this is the same kind of environment for that.
It's exactly the same environment,
Yeah.
and kind of what I was getting towards. Actually, I was building toward that point because functional safety defines best practices going all the way down to component selection, to circuit design,
Yeah.
to software architecture. So it really has to be done in like the earliest stages of your machine development. And if you're a company that doesn't even know what functional safety is, I mean, that's a daunting task to say, well, I know you want your machine built in a year so you can make some money off of it, but there's all this other stuff you have to take care of first too.
Right.
So I think if I were to like bullet point and give one piece of advice, it's take your time and document everything. There's an actual requirement in the documentation, in the standards that require you to take meeting minutes with your engineers in a room,
Oh, wow.
discussing what can go wrong and how you're currently addressing and mitigating errors.
Right.
And it's the document that's generated from that is, used to show we went through as an engineering team and discussed this. And, it's not, Eric, I'm not saying that you have all the onus. If something goes wrong, well, you built it, so it's your fault.
Yeah.
Right. It's a collective onus of the company, at least here in the US. That's actually a very big difference between Europe and the US when it comes to functional safety things, and why I think functional safety is bigger in Europe than it is here in the US. I don't know if you know this, but let's pretend that your machine has a fatal error and someone dies. In Europe, you as the engineer who designed that system take responsibility.
Oh, wow.
Not your company. Here in the US, it's more likely that your company gets sued.
Yeah.
But in Germany, no, for you, it's a fine and jail time.
Oh my gosh.
So I think that's part of the reason why there's such a big focus on functional safety in Europe, and maybe why it's slowly moving here, but not quite as big.
Yeah.
But there are absolutely companies out there like HYDAC, for example, that can offer training.
Right.
But there are other companies that can help support a young company trying to do this for the first time.
So what do you see then as the kind of the future as you move forward with this? It sounds like it's still a growing practice here in the United States. How would you describe, what are some emerging trends or developments that you think are going to happen in the short term?
So we mentioned it earlier, getting a smarter machine, right? Automation and autonomy. So by definition, these trends are asking our machine to have smarter software and to possibly integrate controls that have various operator assist functions like return to working position, auto grade, auto level, virtual barriers. You're seeing all these taglines and cool features people want to implement. Each of these operator assist features are pretty cool. I mean, they're increasing efficiency of the skill of a guy like me to a novice operator to be pretty close to an expert just by clicking a button or holding a switch and flipping a bit in software. But, when you think about it, those features either some way limiting, altering, or changing operator input. and therefore could be viewed as machine movements without operator command. And I can tell you, in the world of safety, even just the thought of unintended motion or uncommanded motion, I mean, that's a big no-no.
Yeah.
Those are scary words.
Yeah.
So I would say the more control and more decisions we give to the machine and to the software, the more robust and tandem and more thorough we need to be when we evaluate the safety of our machines, how we decide how to handle potential errors and maybe how we detect these errors. But in general, if you talk about just emerging trends overall, I mean, I'm excited. I'm excited to see how these OEMs are integrating more of these features in the off-highway space. And I like to think that maybe my kid one day will work on mobile hydraulics, but even if they don't and they just see them on the road, I would hope to think that these machines are safer and more productive than we have today.
It seems inevitable that they will be, with all this focus and increasing so on not just the automation, but the functional safety concerns. It's a good thing all around, it sounds like.
Totally agree with you, Eric.
All right, well, then that is going to wrap things up for this episode of Fluid Power Forum. My thanks again to Marcus Herrera of HYDAC, who has been my guest on today's show. If you'd like to connect with Marcus, learn even more about functional safety, you can drop him an email, and we will put a link to his email address in the show notes for this episode. Remember, if you like our podcast, please follow us on LinkedIn. You can find us there at the National Fluid Power Association. And make sure to keep sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We truly want to hear from our listeners about the kind of topics that you want to hear addressed on the show. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.